Hi guys, I am doing pages 14 to 16. You're not going to hear Kirk today, but listen, if you would rather go, feel free. You're not going to hurt my feelings. Just Google it, okay? You can also always scan the QR codes. The QR codes take you directly to the videos. So we're talking about measures of central tendency, and measures of central tendency are mean, median, mode, okay? They're data summaries. Okay. So, like, if you were trying to explain something to somebody and you're not going to give them all the data, you're going to be like, yeah, here's this. You're going to be like, oh, well, the average is this. Okay. And those are measures of central tendency. They are used to describe the data. Okay. So we look at two things when we look at data. We look for a measure of center, and we also look for a measure of spread. Spread is another word for variation. And variation, it's exactly as it sounds. It's how much do these things vary? Is everything close together? Is it symmetrical? Things like that. So we look at basically two things, but three things, because we look at range, and there's two types of range. There's the range, high minus low, and there's interquartile range, which is Q3, quartile 3, minus Q1. And basically, the reason we look at that, and that's the box from the box plot, is that's where the middle, the 50% of the middle of the data lies. So that's what we would consider like the norm of the data, okay? So we look at the IQR. And basically, to find the IQR, I'm going to do one by hand, the old-fashioned way, and then I'm going to do one on the computer. So first you have to find the median. So you count the number of data points you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I'm counting 17, so I'm hoping that's good. So I'm looking for the ninth data point. 1, 2, 4, 6, 8. This is the ninth data point. So the 7 is the median. Okay. So then I'm going to divide the other halves, the top half and the bottom half, into quarters, quartiles, quarters. So this would be 4.5, and this would be 9.5. And then, so Q1, 4.5, median, 7, Q3, 9.5. And to find the IQR, you just do 9.5 minus 4.5, which equals 5. Now, if this had been actual like data that had a label, it would be like 5 ducks or whatever it is, okay? The label of the data is the label of the IQR. Okay, so now I'm going to show you this one on the graphing calculator. So again, you would turn on your graphing calculator, you would bring it up, whatever. You hit the word stat, you hit enter for edit, and then you're going to type in your list. So you got to clear out whatever stuff you have. You can also type over the stuff you have. So I'm going to do a little type over here. 5, 5, 6, 6, 7, 7, 5, 5, 6, 6, 7, 7, 8, 8. Boring data, right? 9, 9. Yeah, data is not usually that's boring. It's actually usually exciting. Okay, so then what you would do is you would do stat over to calc and one var stats, one variable stats. You hit enter. There is no frequency list this time, so I got to clear that out, and then you hit calculate. Now, it doesn't give you the IQR, but it gives you all you need for the IQR. So if you scroll down a little bit, you get the 5-number summary, and you do Q3 minus Q1, so 8 minus 6. So that would be 8 minus 6, which equals 2. Okay, so data set 1 has a spread of 5 units. Data set 2 has a spread of only 2 units. So we would say if we were comparing these two data sets, that data set 2 has less variation. Okay, so the interquartile range gives a good measure of how the spread of data, how spread out the data is. But the best measure of variation within a data set is the standard deviation. The actual calculation of standard deviation is complex, and we're not going to go into it. We don't really go into it this year. Algebra 2, guys, you will get into it more in Algebra 2. We're just going to use the calculator. Okay. Using the same data sets above, use your calculator to produce the standard deviation shown as, oh gosh, can't remember what that symbol's called. I forgot what it's called. Ooh, I want to say mu, but I could be so wrong. So I'm going to say standard deviation. That I'm going to do. And I'm going to do data set 2 first because I already have that data in. So here's the calculator, data set 2. It's right here. It's 1.4. Okay, 1.4. All right, so that is 1.4. Okay, so now for data set 1, I will go to the calculator and I'm going to enter that data set. So I go to edit, I hit enter, I clear out this data set. All right, I'm going to type this in. So it's 3, 3, 4, 4, 5, 5, 6, 6, 7, 8, 8, 9. Whoops. Oh my gosh. Bad typing. Got to fix this. You've just seen my typing dilemmas. 4. Okay. 3, 3, 4, 4, 5, 5. Enter. Come on. 6, 6. Come on. 7, 8. 8. 9. 9. 10. 10. 11. 11. Okay, there we go. Okay, so now it's stat, arrow over to calc, down to 1-bar stats, and hit enter. And again, there is, I hit 2-bar stats. Not what I'm doing. Go back. Clear. Okay, stat, calc, 1-bar stats, calculate. Okay, so there we go. The standard deviation is 2.65, so we would round that to 2.7. 2.7. Okay, the standard deviation of a data set tells us, on average, how far a data point is away from the mean of the data set. The larger the standard deviation, the greater the variation within the data set. It's pretty simple. So basically, when we have data, okay, so like if I was to plot this in a dot plot, I would want the data to kind of look like that, where 50% of it is like right in here. And that means that it's symmetrical, and that means that it doesn't have great variation, which is, what you want. That doesn't happen. Like, not all data falls nice and pretty into that. Standard deviation, it tells us about that variation. It tells us how far apart things are spread. Okay? A farm studying the weight of baby chicks after 1 week of growth. They found the weight in ounces of 20 chicks. The weights are shown below. Find the mean, the interquartile range, and the standard deviation, round to the nearest tenths. Okay, so all of these are going to be in ounces. So this is going to be ounces, this is going to be ounces, this is going to be ounces, because you have the same label as your data set. Okay, so I'm going to go to my calculator and I'm going to type in all this data. Now notice that this data is not in numerical order, and that's absolutely fine. If you don't like that and you want it in numerical order, you can always do a sort. You have sort ascending and sort descending. Oh, excuse me. I felt like I was going to sneeze. It's a high pollen count day. Okay, so here we go. 2, 1, 3, 4, 2, 2. Oh my gosh, the typing again. Let me try it again. 2, 1, 3, 4, 2, 2, 3, 1, 5, that's a fat little chickie. 3, 4, 4, 5, 6, 3, 8, 5, 4, 6, and 3. So you notice the number in the parentheses. I'm pointing to it as if you could see my screen here. Right here, this 20. That tells you how many data points you've entered. So like when it says 20 chicks in the words, I'm glad that there's 20 entries because that means I probably entered it correctly. So then you hit stat, arrow over to calc, 1var stats, make sure your list matches, and then calculate. So the mean is the X with the bar, and this is the summation, and I wrote all that out. I typed it all out on page 13, so I'll pull up page 13 for you. I actually wrote all the directions on page 13 so you can see it. Okay, so look at page 13. All right, so I'm just going to copy this down. There we go. And I'm going back to my paper. Okay, so that says ounces, by the way. It's not O2. All right, so this was 3.7, and that's in ounces. And this is 5 minus 2.5, which is 2.5 ounces. And then this would round to 1.7. So what does that mean? Okay. What this means is that your average chick is 3.7 ounces. And if I go this way and I add 1.7, that would be 5.4. Then if I go this way and I subtract 1.7, that would be 2. So what that's telling me is that the bulk of my data, the bulk of my chicks, most of my chicks are between 2 and 5.4 ounces. And that's really what standard deviation tells us. Okay, here we go. A marketing company is trying to determine how much diversity there is in the age of people who drink different soft drinks. They take a sample of people and ask them which soda they prefer. For the 2 sodas, the age of the people who preferred them is given below. Okay, so you got 2 sodas and the ages of people that prefer them. All right, so they want to know how much diversity. So when you're looking for diversity, you want standard deviation or IQR. The mean is more of a summary, but standard deviation tells you about variety or diversity. So standard deviation is better. Oh, can I type on this? I don't know. Think about those things. Standard deviation is better as it is a measure of spread. And I could probably be a little more articulate when I say this. Basically, the mean gives you the typical age. The standard deviation gives you the variety. Which soda appears to have greater diversity in the age of people who prefer it? All right, so, there's people age 16 and people in their 40s for the first group. And then in the second group, there's people ages 18, but nobody over 30. It only goes up to 30. So I'm going to say A has greater diversity because its range is larger. It has a larger range. And you could actually show the range if you want. 40 minus 16 is 24. And then the other one is 30 minus 18, which is only 12. So you could definitely show that. Okay. Any questions? Okay. So now, standard deviation. There's two types of standard deviation. There's sample standard deviation and population standard deviation. For this course, we will tell you which one that you are using whenever we ask the questions. So you would know whether to use the one that looks like an S or the one that looks like that, okay? So in order to do this, I would enter everything into my calculator, and I know you've seen me enter this stuff into my calculator before, so I'm not going to show you the work. So for the first one, the SX for sample A, that was equal to 9.1. And then for sample B, the standard deviation was 4.1, which supports my answer. Okay, because if you have a smaller standard deviation, you have smaller variation. Okay. All right. So again, population versus sample. Now, we will use sample most of the time because we don't assume that we have the entire population of things. But at this grade level, we always tell you which one. When you do Algebra 2, they will get more into depth as to making you choose which one. But we're going to always tell you. Okay? All right. So last question. Which of the following data sets would have a standard deviation population closest to 0? Do this without your calculator. Okay. So, choice 1, they vary very little. No, they go from, I'm sorry, that's a -5. Okay, so that's a range of 10. And choice 2 is a range of 15. Choice 3 is only a range of 2. So I'm going to go with choice 3 because it has a smaller range. Okay. And actually, if you think about it, here's 12, right? So 11 is one smaller, but 13 is one bigger. So they're going to kind of like cancel each other out or zero out. And then you got another 11 and another 13, and it's the same thing. So since one is one above and one is one below, they're going to like cancel each other out like that. Okay. All right. I hope that makes sense to you. Okay. All right. So here's the homework. I'm actually going to tell you to do page 16 all by yourself, and you really don't have to do page 17. You can if you want to. So just do this page by yourself, and if you have any questions, contact me. You can skip page 17, but if you want to do it, it's not like it's bad. I just, figured the weather's getting nicer, maybe a little more free time for you guys. All right, so let me just one more time show you this calculator. Okay, so all of this is written for you on page 13, and I wrote it out. It says TI-84 Guide to 1-Bar Stats, and it tells you everything that you need. Now, you only, at this grade level, you only need to know about X with the bar over it. That's the mean. And you have to know about sample standard deviation and population standard deviation. And they're always going to be close. N represents the number of terms. And then that's your 5-number summary. So you can refer back to page 13 if you want. And basically, that's it for today. Just really, the only thing new is standard deviation. Standard deviation is a measure of spread, okay? So measures of center, mean, median, mode. You use the mean most of the time. You use the median whenever there is an outlier or something is non-symmetrical. Measures of spread, range, also interquartile range, and standard deviation. Have a great day.